All right, so let's take a look at the last two problems. That's number 7 and 8. Wanted to start a little bit of a strange spot here for number 7, but I'm going to jump into a little bit of Desmos here. And in Desmos, I just have a nice little exponential story. I have something to the x power. And remember, we should know that we can have all these various bases of an exponential. And if a is between 0 and 1, it can't be 0 and it can't be 1, but any value in between, we have exponential decay, right? This is decaying at 60%. This is decaying at 40%. It's the value underneath the number 1, right? This would just be a 20% decay rate. You notice that depending on the value, you can see how quickly the thing approaches the asymptote. But if we come above 1, the same thing happens. That's 120%, 140%, etc. And the bigger that value is of the base, the stronger it appears to approach that asymptote. But it still approaches the asymptote. There's no change there. Now, one thing to recall is that when we deal with a logarithm is the inverse of an exponential, which reflects the line across that diagonal. And so when we reflect that, we have this green one right here, which is my logarithm. Now I'm going to turn this off just so we don't have quite as much stuff going on. But yet again, you can see it doesn't matter what the value is. It still has a very strong asymptote at 0, right? And the bigger the value is, the stronger that asymptote is, but it still is getting close. I mean, I guess the more rapidly it approaches it, if we go to those values between 0 and 1, it just has kind of flipped the value over, but it still is getting close to 0, but never touching 0 because that's where it came from in the exponential story. Now, as such, that answers a domain question. It does not matter what base your logarithm is. The log is only going to be allowed to be taken of positive numbers. You cannot take the log of 0. You cannot take the log of negatives. So as such, that means we can now answer that question. So keeping in mind that I'm only allowed to take the log of positive numbers, well, then on this particular problem, remember, I can only take the log of positives. So somehow this 3 minus x value has to be specifically above 0 because I can only take the log of positives. Well, what I do is I just go ahead and find out where 0 was. And please understand, I know that 0 is not something I can take the log of. It just is right on that borderline of where I can and cannot go. So what would happen if I picked a number above 3, like 6? Well, 3 minus 6 is negative. I can't go this way. So the domain of this particular story is x is less than 3, because that is what would do that. Now, keep in mind, graphing by transformation, remember we said never let anything be attached to x. So we could say that my original natural log, like this, it got flipped over the x-axis because that's what the negative right here would do, and then shifted to the right 3. So when we shifted it to the right 3 and flipped across the x-axis, it looks like this, and you can again see that the domain value is only values below 3. Now, we didn't really need a graphical image to understand that, but maybe it helps. Now, for part B, we have something that's a little bit interesting here is again, you can only take the log of positives. So I know that -4 is definitely not going to be possible, but I also know that -1 isn't really possible either. And I don't know why I wrote it that way. The number -1 would not be possible either because I can't divide by 0 either, right? And so what we'll find out is that if the numerator and the denominator were both positive, I could do it. And if they're both negative, I could do it. But I just cannot be somewhere in the middle. So my domain would be all values from -infinity to -4 or from -1 to infinity. And that would satisfy my story. Okay. Now, when it comes to graphing, What we talked about here is making sure we have a quick little table of information. I would say that my parent function is going to be 2 to the x. We could have a couple of simple values where maybe we had -1 giving me 1/2, 0 maybe giving me 1, and I'm jumping up a little bit. I went to 2 gives me 4, so the values at least are spread out a little bit. And I should know that if f of x equals this, if this is f of x, then g of x is f of x plus 1 and then minus 1. So keep in mind, I replaced x right there with x plus 1, and the minus 1 happened at the end, so that I know that all of my y values are going to go down 1/2, down 1, excuse me, and all my x values are going to go to the left 1, so it'd be -2, -1, and in this case 1. And the original asymptote y equals 0 is now going to be y equals -1. So I'm going to have a nice little asymptote. I need to put my glasses on because I want to be careful about the spacing on this graph. The asymptote right here is going to be at y equals -1, coming right down the middle. And at -2, I've got -1/2. I think we're counting by halves here. At -1, I got 0, and at 1, I've got 3. So the graph is looking about like this. And I want to be thorough. I'm going to call that A, B, and C. And hopefully that works out okay. Now, this guy over here is going to have a parent function of 3 to the x. Okay? So just like before, I'll go -1 giving me 1/3, maybe 0 giving me 1, and 1 giving me 3. Or maybe I could do 2 giving me 9. It doesn't matter. I could pick any number of values. It doesn't matter too much. So what I see, g of x was f of x. But what we're going to do is we're going to be replacing 2 is going to go in the front, and this x became negative parentheses x plus 4. And so keep in mind, as we do that, any number on the outside is going to affect strictly the y values. So my original y equals 0 is still so. I would say all of my y values are being doubled. So I got 2/3, 2, and 6. And my x values are going to get flipped and to the left 4. So flipped is 1, to the left 4 is -3. Flipped is still 0. 0 flipped is 0, and to the left 4 is -4. And 1 flipped is -1, so -5. And there should be a nice simple little pattern. So it looks like I've got a horizontal at 0. I've got -3 right here, giving me about 2/3. I'm going to estimate about that spot as A. -4 is going to give me 2. There's B. And -5 out here is going to give me 6. So my values are a little bit mixed into my table. And that makes sense that the graph is going that direction because of the reflection across the y-axis that's sitting right there. Okay, now off to logs, the fun one. Now I gave a lot of space on this because in my head it just makes a lot more sense. So I personally really like to start with 2 to the x as my parent function. Then I go to the log base 2 of x, and then I do some movements of that. So here's my x, my y equals 0. I usually start with some simple values as we've indicated, right? A log is an inverse, so all of the x's become y's, the y's become x's, right? And then last but not least, we're going to jump in here and talk about what f of x is. And we are going to take this graph right here. We are going to double all the y values because that's sitting on the outside, -204. And we're going to subtract 4 from all of the x values. So if we subtracted 4 from all of the x values, That's going to be -3.5, -3, 0, and x equals -4. And that should be plenty to get my answer. So I have a nice little asymptote at x equals -4. I always label those nicely. A, B, C. At -3.5, about here, I'm going to go down 2. At -3, I'm going to be at 0. And at 0, I'm going to have 4. There is, oops, that's B, and this is C. And off we go. So remember, logs get really close to that asymptote, and then they kind of pan out this way, and they become somewhat flat, but there is not a horizontal asymptote. It's growing that direction, but it's just getting flatter and flatter and flatter because remember, logs take a long way. In base 2, which is the base we're talking about, it took 16 units to the right normally to hit a height of 4, and 32 units to the right to hit at 5, and 64 to hit 6. So it takes, every single time you would double the previous gap just to raise one additional unit, all the way to 128 to reach the number 6. They grow, but very, very slowly. And then our last one right here, remember, never let anything be attached directly to X. So I think I'm just going to write the table on this one because as far as making the graph, I'm quite confident you can handle. So we're going to look at 3 to the X to start. 0, let's see, X and Y. 0 would be 1, 1 would be maybe 3, and maybe -1 would be 1/3. I probably should have done that in better order, but oh well. We're going to swap our X's and Y's. I'm going to put this back in order the way I should have originally, but that would be 1/3, that would be 1 and 3. And then last but not least, our little table here says, let's go ahead and take all of our Y values and multiply them by 4. So that does tend to happen sometimes on these problems, exponentials and logs. Sometimes you're going to go off of your paper because of how quickly things move around. Feel a little bit awkward about this. I messed this up, didn't I? I did. Let's go ahead and back that out. I was being silly. I don't script these lessons, so I sometimes am just trying to go as quickly as I can. I forgot to move things. That is 1 giving me 0. That's 3 giving me 1, and 1/3 giving me -1. So I forgot to flip those. That's going to make things fit a lot nicer than they should. So we're going to multiply everybody by 4. And like I said, I'll put them back in order. If I multiply by 4, I get -4, I get 0, and I get 4. I'm going to flip all of my X values. Let's see, let's go ahead and do this one right here. Man, I wish I'd done this differently. I'm going to do this one first. So I'm going to flip my X value, which makes it -1/3, and go to the right 2, which is going to be 5/3. I'm going to do this one next. The next largest, I'm going to flip it, which gives me -1, and I'm going to go to the right 2, which gives me +1. And then I'll do this one right here last. I'm going to flip it, which gives me -3, and go to the right 2, and that gives me -1. Okay? And X flipped, 0 flipped is still 0, and go to the right, I would have X equals 2. And you'll notice that 5/3, which is 1.666, is fairly close to the number 2. And so hopefully that works. Sorry for the little mistake that I made right there, but I hope that works out for you. And I will see you guys back in class later. Hopefully that was helpful. Bye-bye.